Hey guys, in this video we're going to review a little bit on how to solve triangles, specifically right triangles using SohCahToa Trig. And so really quickly here, what we want to lay out is that in a right triangle, of course, if we look at one of the two acute angles in the triangle, we'll just pick one of these, the base angle here, and call it theta, we would look at the sides in relation to this angle and refer to these as either the side that's opposite, the side that's adjacent, the side that is the hypotenuse. And so with respect to SohCahToa Trig, we just want to kind of remember what these sine, cosine, and tangent functions are really relating. So when it comes to sine, what we want to remember is that what we're doing is we're taking the side opposite and dividing it by the hypotenuse for our sine function. When it comes to cosine, we're going to divide the adjacent side by the hypotenuse. And when it comes to tangent here, we're going to divide the opposite side by the adjacent side. So looking at all of these triangles you see up here, because they are all right triangles, then we can use SohCahToa Trig to help us solve for some of the unknown values. So we're going to start with this first one here, and the very first thing I want you to just notice is that we already know one of the two acute angles here. And so one thing could be said about these two acute angles in a triangle: if all the angles add up to 180 and 90 of those degrees are right here at this right angle, then the other 90 has to lie in the other two angles. So first things first, if you ever know one of the acute angles in a right triangle, the other acute angle must be complementary to this. And so we would say that this angle C here would have to have a measure of 56 degrees. And I'd actually be inclined to go put that on my picture. Now, with respect to A, B, and C here, I suppose that we would need to know at least one of these three values to begin with. And so in terms of what I have, I actually do want to go and make an amendment here. Let's call our A 4. And so what this means is I kind of forgot to put a side length on one of these, but going with the fact that maybe A is 4, could we go find B and C here? So let's go ahead and start with C. The fact is I do not know what C is. However, if I could relate it to one of my acute angles here and one of the other sides using SohCahToa Trig, then it would be the only thing I don't know, and I know two other things, so we could go solve for it. So I suppose the idea is this: if I pick an angle here like my 56-degree angle, how could I relate that 56 to the side opposite over the side adjacent here? And so I would say that in this case, opposite over adjacent means tangent. We're just going to say then the tangent of this 56-degree angle here would equal the opposite over the adjacent side. Now, something like this would be nice because now all we need to do is really go solve for C here. Remember that we could just quadruple both sides, or we could multiply by this constant down in the denominator to get the value of C. So 4 tan 56 degrees is the value of C. I'd put a box around this, but with respect to what this actually equals, here's where your calculator comes in handy. And so we are going to go ahead and take 4 times the tangent of 56, and we get about 5.9 if we're rounding out to the 10th spot. So I'm going to say this is about 5.9. I'd be inclined to go put this on my diagram up here, but now we need to go solve for B. So perhaps we use the same angle here, 56 degrees, but this time we're going to relate it to, it looks like, these two sides, the side adjacent and the side that is the hypotenuse. So in this case, adjacent over hypotenuse, that would be ca or cosine. So we're going to say that the cosine of our angle 56 degrees would be equal to the adjacent side over the hypotenuse here. And so we get this 4 over b. Now, it's good that we're talking about this because anytime you have the unknown in the denominator, what we need to do is go ahead and start by multiplying it up first. So we get b cosine of 56 degrees equals 4, but then we have to turn around, we have to divide both sides by this cosine of 56 degrees here. So doing so actually gives us the value of b. We say b is 4 over the cosine of 56 degrees. And again, we would just go get a value for this on our calculator. So 4 divided by the cosine of 56 degrees. In this case, we would get about 7.15 units here. So B would be about 7.2, and I would go put this on my image here and check for reasonability, but it looks pretty reasonable to me. So 14 is very similar to number 12. The only difference is that we know neither of these interior angles, and we know 2 of the sides. So let's go ahead and start with this. If you know 2 parts of any right triangle, then we can relate these using the Pythagorean theorem. So that is to say that 3 squared, or a leg squared, plus the other leg squared, z squared, would be equal to 5 squared. So go ahead and simplify this. We get 9 plus z squared is 25. Let's go ahead and subtract the 9 from 25. We get 16, and so we get z is plus or minus 4. Now in this case, I'm going to go ahead and keep just the positive 4 because we're not really relating this to any particular quadrant, and so it's just a distance. So I'm going to write z is 4. Now solving for one of these angles, again, it's a right triangle, so we're going to relate this with SohCahToa Trig. So if I want to solve for x, let's go ahead and do this. Let's find 2 sides that we already know to relate x to, and because we know all 3 sides, we could use any of our trig relationships here. So how about I do this? The sine of the angle x. Now I don't know x, but I do know the sine of this angle would be opposite over hypotenuse. Or in other words, 4 over 5. So solving for an angle, recall that what we need to do here is use an inverse trig function to work backwards from the ratio to the angle. So taking the sine inverse of both sides, we get just the angle on the left, and that would be the sine inverse of 4/5. So checking this out, this would be our exact value. Let's get it on the calculator here. I would say that the sine inverse of a 4:5 ratio would mean that we have to have, and let me go back and put my 5 here, we have to have about a 53.1 degree angle. So I'm going to write 53.1 degrees. I'm also going to write it in here, but the neat thing about this is because it's a right triangle, if I take this away from 90, I should get the other angle, or the complement to this angle. So 90 minus my answer here, this means that the other angle is about 36.9 degrees here. So we get about 36.9 degrees. So SohCahToa, you know, as long as you know a side and two other parts here, that's great, but if you know a side and two other parts and it's a right triangle, you're in very, very good shape. So let's take a look at 18 as this last example. Basically, what I want to be able to do is find our 6 trig ratios of this triangle right here given the angle theta. And so we notice that we know all 3 sides. We don't need to use Pythagoras here. We just need to relate our sides to one another. So we'll start with sine, cosine, and tangent. Then we'll go and get their reciprocal. So sine would be opposite over hypotenuse. Opposite this angle theta would be our 12, and the hypotenuse is 13. So this means that our sine value is 12 over 13, whereas cosine adjacent over hypotenuse would be 5 over 13 because 5 is adjacent to this angle over the hypotenuse here. So we get 5/13. And then last but not least, our tangent, opposite over adjacent, would be a 12:5 ratio. So keeping that in mind that these are our initial ratios, then these must be our reciprocal ratios over here. And just keeping in mind also that cosecant's the reciprocal of sine and secant's the reciprocal of cosine. They're not always listed in this nice convenient order where they're across from one another. So just be mindful of that. Cheers.